All right. Hey, what's up, everyone? Good morning. It is Monday, August 24th, and we're going to go ahead and get started with the online lecture portion of this class. I'm going to make some videos, try and keep them short. I recognize that, first, that students are going to be able to uh, play this at 2x speed. So I want you to remember that it's going to take me 2 or 3 times as long to make these as it does for you to watch them. So I'm going to try and keep the course pretty much kind of structured so that we don't start getting ahead or getting behind, and just that it just runs smooth. It's beneficial for you to go into module one and print out, or if you want to take notes on your laptop or tablet or iPad or whatever you have, you want to either print the notes or you want to use the Word document to complete the note packet, or you can do that through PowerPoint, whichever one works best for you. But you're going to use the notes to make note cards to take the open note quiz, and that open note quiz is going to be part of half of the notes from the quiz are going to come. The exam will be from the quiz, and then the other half of the exam is going to be from whatever wasn't on the quiz, and it's pretty straightforward. So it's beneficial if you either print those notes or have those ready to go while you're taking notes and watching these videos. Some of us are plant science and some of us are animal sciences, and maybe we're ag business or, ag engineering technology, whatever the case may be. It is important to understand the benefits of plants because if we didn't have plants, we would not be here. In that, for the most part, that they provide us a source of oxygen. So plants breathe in carbon dioxide, they breathe out oxygen, we breathe in oxygen and breathe out carbon dioxide. So there's this mutualistic or beneficial sort of symbiotic relationship between us and plants. They're going to give us some soil stability. They provide habitat for wildlife. It's our building materials, our food sources, and then also, some aesthetics. Like it's nice to have a pretty yard. And so there's this statistic that shows that, a 250 square foot yard provides enough oxygen for a family of four. So plenty of benefits to having plants, because again, without plants, we would not exist. See here. Oh, there we go. All right. So the agriculture really started a long time ago. In we had this hunter gathering sort of nomadic movement of people because whether it be weather or whether it be um, uh, could be predators or whatever. They had to figure out a way to gather food. And so once they picked all the food from a certain area, they sort of moved on. And at some point in time, they realized that that was just not the wise thing to do. And so they began sort of breeding and cultivating their own crops so that they didn't have to travel as far. They could grow it once they found a nice, safe place. They started to domesticate those crops. For the United States, generally rural populations are going to produce the majority of the food, and they're going to ship that into the city. Um, you know, Only about 20% of non-metro counties were considered even farming dependent. Everyone, we sort of have this thing in agriculture. It makes sense to us, but not to others. That that chocolate milk doesn't come from brown cows, and that we don't get our food from Walmart. Someone has to grow this in order for us to be able to consume it. And sometimes that can get lost on the general population. They're just unaware because it's so commonplace for them to just walk into Walmart and get what they need. So we have two sort of fields in agriculture when we're talking about plant science, right? We've got agronomy and we've got horticulture. And so agronomy is what I do. I'm an agronomist. I am mostly interested in growing corn, cotton, and soybean. There are some other ones that I could grow as well because it's part of agronomy, but in general, my background is corn and nitrogen. And then we have horticulture. And so these are going to require more intense and constant care. If you worked in a greenhouse, that's an everyday job. So for field grown crops, it might be an everyday mission that I have to go out and check my crops every day just because I'm checking them. But I don't have to do a whole lot. Once I plant the corn, and if I get enough rainfall and there's enough nutrients, and maybe I have to go scout for weeds or insects or whatnot. But for the most part, like I don't have to monitor them every day. However, in horticulture, you really kind of need to make sure that your crops are getting watered and that you're checking them every day. So you're going to go into the greenhouse because you're growing them in a very small sort of micro environment. And we'll get some overlap. Something like tomatoes, we can grow tomatoes in the field. And we can also grow them in the greenhouse. So agronomy and horticulture, similar, but also different in the intensity and the care and the attention that I need to provide them. And so we're starting to see more of, the agriculture trend that we're trying to get away from Walmart. We're trying to get away from um, the intense cultivation, in that we're using a lot of chemicals that we may not want in our food supply. So we're going to start to see more a shift towards more farmers market, to more, I don't want to, and I really don't want to say something like organic, but I want to say something that is less chemically dependent. And so that we're growing things that are, heirlooms, maybe non-GMOs, but you might pay a little bit of extra money for that when you go to the farmer's market. And I think that since food prices are already skyrocketing, why not pay an extra 50 cents or a dollar to get something that you know is going to be more healthy for you? We really had this push towards sustainable agriculture because of the Dust Bowl in the 1930s, and that we didn't have crops, or we didn't have anything on our soil that sort of held it in place. And if you don't have something to hold that soil in place, well, then you get this sort of dust cloud. And when you pick that up and you move that somewhere, there's definitely some negative impacts in that. So we're going to define sustainability as the ability to be maintained with little input of non-renewable resources. And for like non-renewable resources, soil is a non-renewable resource. It takes 1,000 years to make 1 inch of soil. That's not renewable. Okay. Water, a non-renewable resource. The water that is on this planet is the water that is on this planet. We cannot make any more of it. Some of the domestic trends, we're starting to see that, corn and cotton and soybean and wheat, our yields are increased. We're starting to get a decline in the outcome. This has to do definitely with, certainly with supply and demand and ag economics. And I was talking to my sustainability class about this, that if you create a shortage, or at least the perception of a shortage of food, so you decrease the supply, what happens to the demand? Well, the demand would increase. And when the demand increase, the prices increase. And so it could be that there is this sort of fear mongering that we don't have enough food, even though we probably do, because we have producers who could not sell their corn. There was so much of it that they couldn't sell it. So, sometimes the government will subsidize that so that they can maintain some balance among that, and they can sort of keep everything balanced the way that they see fit. So we're starting to see the number of farms and also farm workers declining. There's a statistic for Tennessee that we lose at least 1 million acres of farmland every year. We're losing that to, urban sprawling, population with this population increase that we're expecting there to be more people. But actually, there's not a population increase. Like, it turns out that we're actually in a population decline. And so once we build those houses and once we take away that farmland, we're not likely to get that back, because they've invested so much money into this housing development that they can't turn it back into farmland. All right, we'll move past some of this here. Oh. Something that we're doing is that we're making new cultivars that are high yielding. We'll talk about this a lot more in Module 4, when we're trying to develop new crops that are better. And so whether you're animal sciences or plant science, if you're animal sciences and you're taking this course, then, the hybrid vigor is something that you might have heard of before, and that we're going to breed something like a Sim Angus, and we get the best of both traits, or, the best of both species. And we are going to create a new, I really don't know what y'all call those, but we're going to get a new breed. That's the term. You're going to get a new breed, Sim Angus, that has the best of both breeds. China is actually one of the major challenges to the world's food supply because they have the highest population. There's almost 20% of the world's population. And I talk about this population increase and population decline. China and those Southeast Asian countries that were sort of trying to minimize their population by making laws that you could only have one child are now allowing couples to have two children. So think about that, that China recognized they were having a population decline and that they are going to need to increase that. We need yield increases. And so that if we increase our yield, there was this big push probably, 5 or 10 years ago that we needed to increase our yields by 70% so that we could meet this growing population that will be, somewhere between 9 and 12 billion people within the next 70 years. So, somewhere between 2050 and 2100. I don't know that y'all might see that. 75 years from now seems like a long ways away. I know I won't see it. But again, we're actually not in this population increase. We're in a population decline. So we actually have or are likely to experience a food increase, that we have more food than we know what to do with. Yet we still have homelessness and we still have hunger, like food insecurity for a lot of places. We're also expecting our energy use to rise twice as fast as the population. Where are they going to get this energy from? Where are they going to get their fuel? And so at some point in time, we suspect that the oil reserves, the fossil fuels, will eventually decrease. And so in order to stop that, we have tried to move towards alternative energy sources. And we're getting ethanol from switchgrass and from corn. But are we really going to pay for that non-ethanol at the gas pump? Prices are already pretty high. I'm not going to pay extra money because we're running out of the stuff that I already need. So our global energy use is expected to increase within 50% over the next 50 years, and we're starting to see the sort of data center push, and that is going to influence our water supply. Water supply is going to influence yields, because if you don't have any water, then your plants aren't going to grow, right? So we got to have water in order for the plants to grow. Humans need water so that we can actually drink and that we can grow. And so we're going to be sort of in this, when we do something for one thing, we're going to pay a cost somewhere else. And so while we're increasing carbon dioxide, that could be good for crops. We'll talk about this in module 3, because remember, plants breathe in carbon dioxide and they breathe out oxygen. However, rising temperatures could decrease yields. And also, as I mentioned, water availability is going to be important. One of the biggest issues that we're going to see is deforestation. You have to think about that trees are probably the largest consumer of carbon dioxide because they're huge and they have a bunch of leaves. And so they're going to pull that carbon dioxide out of the atmosphere. That's sort of this push for we can't really say climate smart agriculture, but we're going to try to minimize the carbon footprint. And if we're losing 1 million acres of farmland a year to building houses, what are we building the houses out of? That's right, trees. And so once we take the trees out of production, do they get to go back into production? No, because they're timbers, right? They're 2x4s. And do you know how long it takes to grow a full-grown tree? Like 15 or 20 years. So we cut down these trees and then we think that we're going to regrow them, but we're actually not going to, because it's going to take 15 or 20 years. And by then we cannot keep up with that carbon dioxide output. We're also going to get this increase in pest cycles and pest populations because of the increasing temperature. And so for the most part, pests are most prevalent during the summer. And you'll hear me talk about this thing called climate encroachment, and what if we increase our growing seasons. So in a couple more modules, in a couple more videos, you'll hear me talk about that. But we're going to start getting more pests that are going to decrease our crop yields. And how do we combat the pests? With pesticides, which we're trying to stop. So they gave us this mission that you need to grow 70% more yields with less water, less fertilizer, and less chemicals, which is almost impossible. They gave us an almost impossible task. Bioterrorism is going to be a thing that we're starting to see maybe a little bit of, and then why not just hurt people's food supplies? Why not just infect them with, maybe something like wheat rust, and you now decrease their capacity to provide food. And if you can't provide food, well, then they're not strong enough to fight against you, and we can just come in and take over a country. Probably more so in the Middle East than we are in the United States. So it's going to be up to you. Like all that to say, it's going to be up to the younger generation to figure out how to overcome these challenges. And whether you're for GMOs or against GMOs, you're going to have to figure some way out. And currently, what we have is, we're using genetically engineered crops to stop using pesticides because we don't need as much, you know, insecticides or maybe herbicide. Roundup Ready, I think that we all know that is going, or many of us are aware that is sort of shooting ourselves in the foot. Some you'll hear me talk a little bit about golden rice, or maybe some of these apples. We're going to have problems with. We're going to have problems with the global temperatures increasing and not getting enough chilling days, and we'll talk about that in Module 1. So it's going to be up to you in order to come up with solutions to overcome these problems. And unfortunately, that's going to be a huge challenge. I just have this in there. I love this at Tennessee Tech. This is where you're going to spend the next 4 years trying to figure out how to become the solution to some problems that you may not have created, unfortunately. So that's going to be what we do for the next 4 years. All right, so let's get into Module 1, and I want you to think about, I'm going to ask this question in class as well. I want you to think about what would be the ideal environment for you, like temperature, sunshine, number of days, like what would be the ideal environment for you? And that means that plants also have an ideal environment. So today it is August 24th, and it was actually a little chilly this morning. I had to put on my little pullover, and I love it here in Tennessee. The environment is very conducive for me. So, and that's going to be for plants as well. All right, so we've got these terrestrial ecosystems that capture energy from the sun, and we're going to store that in sugars. So the whole purpose of the plant is to conduct photosynthesis to make carbohydrates. Those carbohydrates are what animals and humans need in order to survive. So the climate, how much sunshine, how much temperature they get, how much rainfall that they get are going to be vital for plants to be able to grow. Like there's a reason that we don't grow cotton in Cookeville, Tennessee. It's just not hot enough. We grow cotton in places like Alabama and Mississippi and Texas because we get enough temperature. But we also can't grow things like apples in Alabama. We grow those in Washington State because the climate is conducive for those. So natural ecosystems, which we're going to try to get back to, are definitely more complex than crop ecosystems because we've taken out a lot of the variables and we sort of created this monoculture, which is not good, but it's necessary because we have to grow crops. So our ecosystem components, we've got our physical and environment, and our ecosystem is this community of organisms in a physical environment, much like ours, much like humans. We want to live in a place where the environment is conducive for us. And so you might, I want you to think about that a lot of older people that are now reaching retirement tend to move to Florida because the temperature, that physical environment is good for them because they don't have to regulate their temperature. And it's made up of all these different plants and animals and fungi and bacteria and these microorganisms, and they all coexist together to sort of make this thing a positive environment for everybody. And then we have ecology, which is the study of those relationships and those organisms in their environment. And so maybe you have to take an ecology class, or, and if you can think about it, we're in the school, we're in the College of Ag and Human Ecology, which means that's the study of the relationships in humans and their environment. So ecology is just what is the environment and how can we study that to make it better for everyone or everything that is in that environment. Some of our ecosystem components, we've got abiotic, which is non-living. So these are things like temperature and water, sunlight. We've got biotic. These are our living things. So our earthworms and our beetles and our grubs, microbes, birds, snakes, turtles, whatever, which are all really driven by climate. That's why I asked you, what is your ideal environment? We've got some disturbances. And so for some environments, we are going to naturally burn them, or at least try to do controlled burns, because those are required in order for the turnover for those microorganisms. And then finally, human activities, which are actually kind of like the problem. We are actually our problem because we're out here destroying environments or changing them in ways that they should not have been changed. And we're going to end up paying the price for that. So look at some of our abiotic factors: temperature, light, water, soil. I'm a little on the fence about this because I generally tend to consider soil as this sort of living ecosystem that is important for everything else. And then finally, air quality. If there's not enough carbon dioxide, or if there's too much carbon dioxide, or if there's pollutants in the air and those plants are breathing that in, and even humans, if we're breathing in, lead or sulfur or whatever that is in the environment, like I want you to think about Los Angeles, like that's not, their air quality sucks. So our plants are not going to grow well in environments that have poor abiotic factors. Our biotic factors, these are going to be our living things. So like plants and animals and microorganisms, and they all have to survive together. And sometimes that can be challenging. There's competition. There's going to be, there's going to be some predators. And so if you have too many birds and they're eating up all the earthworms, then you don't have good soil quality. And so there needs to be this balance overall. We're going to have competition for those abiotic factors, such as light and water and nutrients. And so that's why trees tend to dominate in forest situations. They're up higher, they get the majority of the light, and therefore anything underneath it doesn't quite get as much light. Next, we have two things. We have weather and climate. And weather is what happened this morning. The weather outside was cool and such that I needed a pullover. But that is not the climate. The climate is the average pattern of weather over a long period of time. And so, how would you define the climate in Tennessee? Well, we might consider, for me, the climate in Tennessee is definitely much different than the climate in Mississippi. I think that the summers are moderate. They can get a little warm. I think that the winters are cold, because I'm from Mississippi. We don't have very cold winters, but they're not miserable versus the climate, let's say, South Dakota. Their winters are brutal, and they probably don't have very harsh summers. And so the climate is the pattern over a long period of time. The weather is what you check on your phone. That's why it's called the weather app and not the climate app. So the weather tells you what to wear each day, but the climate tells you what type of clothes to have in your closet. So, soon we're going to start pulling out hoodies because the climate is going to be different than it was in the summer. Actually, the weather is going to be different in the summer. So we have our spring clothes, and we've got our summer clothes, which are shorts and flip-flops and t-shirts. And then pretty soon it's going to be hoodie weather. We're going to start wearing sweatpants. and hoodies, and we might even need gloves. I don't do cold very well, so like I've got my parkas and I've got my beanies and I've got my gloves because I don't like being cold. Are disturbances. And some of these are natural and they're just going to happen because the environment, it could rain a whole lot and you get 4 or 5 inches of rain, and that disturbs the soil enough so that you have a landslide and you can't put that back. So many of us might recall that Hurricane Helene came through. This weather anomaly, this hurricane came up the East Coast and hit East Tennessee, which is not likely to happen. It was not expected to get a hurricane in that area, and we lost whole from what I understand. I was talking with a professor from UT, and he was saying that entire layers of soil all the way down to the bedrock were completely washed away. And there's nothing that can be done about that. And so sometimes human activities can play a role in that. But for the most part, like wildfires in California, like they had those every year. Sometimes they're started by people, whether it be intentional or unintentional, but we do have those problems. Sometimes in positive situations where it's common, and the environment or the ecosystem has adapted to those disturbances, that fire is important because it can remove existing vegetation and it can change the soil conditions so that new plants can grow. Next, we've got our human activities, and so we're cutting down these forests because we need the lumber so that we can build houses and urbanization, and we're also polluting, whether it be the atmosphere or whether it be our water systems, uh, and we're putting chemicals in there because we're trying to grow food, but we need less chemicals, but we can't grow food without the chemicals. And so we're sort of in this catch 22, and that we have to figure out a way and to keep our environment sustainable so that future generations don't suffer the consequences of this. All right, so maybe some of you have or have not watched Yellowstone, but there is this scene where Kevin Costner or John Dutton is talking with this environmentalist who is against animals and against all this stuff and trying to keep nature. And what he basically says is that no matter what we do, whether you're trying to minimize something or not, we're impacting the environment. Because whether it is you're trying to, and I'm not saying you, I'm not trying to point at any one person. I'm saying in general, there are people who prefer a more plant-based diet than animal-based diet. And at some point in time, they're going to have to plow a field in order to grow that. And maybe they don't, but it takes a very long time. But at some point in time, we are going to have some negative impact on the ecosystem, no matter what we do. We just need to make sure that we're not doing it in a manner that is not sustainable. So we want to minimize the negative impact, but we cannot stop it. All right, so moving into our ecosystem components, we have population boundaries, and sometimes those can be a challenge. We might get some encroachment, but if you think about this in a more centralized place, like let's say you have a garden at home, that ecosystem, that garden that you have has its ecosystem components, both abiotic and biotic. And so anything that lives in that soil, because you've created this nice fertile ground, there is energy there, there's carbon, there's nitrogen. You're going to you're going to increase the population dynamics or change those population dynamics that are living in that little ecosystem. And so we need to identify those important organisms, the processes for that, because they actually have a big impact. Although they're small, their populations are in the billions. So while they may only do one small little thing, you get a billion of those small things happening, and that makes a major impact. So just a closer look at this, we've got our macro and micro flora, we've got our plants, and we've got things that are kind of growing above ground, the things that are underground that we really can't see, but we have knowledge that they're there. But again, there's billions of these different bacteria and these different fungi and these different grubs. We've got nematodes, microorganisms. We've got big organisms like earthworms. We've got even bigger, bigger organisms like moles tend to tear up our yards. So all of these things play a role in how well our plants survive, whether it be in our garden or whether it be in a large cropping system or whether it just be in a natural habitat. So we've got microflora and fauna. So these are going to be things like our macrofauna, large birds and animals, and then macroflora, things like weeds. And so, how do we get rid of the weeds? Well, I mean, you can go out there and you can hoe them up. There's no shovel resistant weed. But do we have the time and the energy for that? No. So, we might choose to spray some chemical that is going to minimize the impact of those weeds. So, in our cultivated systems, we're going to need to sustain that. Like the processes and interactions in a natural ecosystem are either, absent or heavily modified, in that we've taken this ecosystem. Remember, I said that that natural ecosystems are very complex, but our cultivated ecosystems are not, because we've basically taken all the variables out and we're basically forcing that ecosystem to function the way that we want it to. Whether that's good or not, still up for debate. But remember, we've got to feed 10 billion people by 2050. Or do we? How does that go? All right. Again, more ecosystem components, because we can see this in natural ecosystems. We're actually trying to bring that over to our crop ecosystems. And I saw this thing on Twitter where it was saying that actually when we're growing, like for agronomists, like we're actually harvesting sunlight. It is the harvesting of that sunlight combined with water and nutrients that are allowing those plants to grow, which create our corn or our cotton or our soybean or whatever food supply, tomatoes, cucumbers, whatever. We need the sunlight in order to make that food, because that's where they get their energy from. That's where they get their carbohydrates. And we have to supply other things like more water or more nutrients in order for them to grow. We may need pollinators. And so pollinator species are becoming a hot topic because we need those we need bees and butterflies and regular flies and anything that's going to land in a flower, hummingbirds that are going to take that over to somewhere else and pollinate a different crop or a different plant. If we have those resources that are split out, then species one can handle this part of the resource, and we don't have the competition with species two. Great environment. Great environment right there, compared to where we have both plants competing for this nitrogen resource. And so one of them has to lose. But if the resources are available for each species, that they don't have to compete with each other, then both species thrive. So these species have created their own niche. They found their own environment where no one else is competing for it. Sort of like if you're in the dorm, everyone is competing for the bathroom, or maybe they're competing for the common area and they want to watch TV or they want to do something or other. Or maybe if you're trying to study, everyone is sort of hanging out there. But the best place to study and the most quiet place to study is the library. And so that is your niche in that, or niche, however people are going to say that. That's your niche. That's your place where you don't have to compete for peace and quiet, and you can actually focus on doing what you're supposed to be doing. So plants have developed that as well. Unfortunately, those niches tend to be available for other plants such as weeds because they also don't have to compete, and they found a place where they don't have to compete with other weeds and they can compete with plants. They have enough sunlight because maybe the the plant that is growing there doesn't have a very large canopy, and that allows them to grow as well. So one of the best ways to minimize weed populations is to take away sunlight, because if the sun, I mean, if the weeds don't have any sunlight, then they can't grow. Here's a look at those three sisters. This is a great example of that. And then we're going to grow three things that are really going to benefit each other um, overall. So we're going to grow, in this particular instance, we're going to grow corn, and we're growing beans, which are likely to be some sort of legume. And then we're going to grow squash. And squash has this very large cover that is going to minimize the sunlight for the weeds that are not going to take up the nitrogen from the supply for the corn, but the pole beans are actually going to increase the nitrogen supply. So we're sort of getting this um, symbiotic relationship, that there's enough light that comes through for the beans and the squash, and then the beans are providing some nitrogen content for the corn, and the squash is providing the cover over the soil that minimizes water loss, that minimizes sunlight, that minimizes any sort of weed competition, and they might not need as much nitrogen. So those are going to be things to think about as you move forward, in case if you're one of those people who wants to have their own little slice of heaven and they want to be this self-sustaining sort of off the grid living system. Our pollinators, and we've got these insects, and they have their own little domain and their predation and uh, their life cycles. And so if you start to get too many predatory insects, then they're going to eat up all the beneficial ones. But you can also do things and have beneficial insects that are going to eat up the parasites. And so one thing that we do in greenhouses is we bring in ladybugs, because ladybugs eat aphids, and aphids require us to spray chemicals. So if we have this biological control and we know that ladybugs are going to eat aphids and they're going to seek those out, well, then we don't have to spray any chemicals. So as you start to go through some of your other classes, if you're at least in any sort of plant-based, whether it be horticulture or agronomy or some sort of plant science, you're going to hear about these beneficial insects. We have diseases. And so the diseases, we can do some things to cultivate that, and keeping airflow and minimizing water, because fungi love water and they love humid conditions. And so if we can get enough airflow, we minimize the ecosystem or the environment in which these viruses or the bacteria or the fungi thrive. So we're sort of taking our knowledge of ecosystem components, knowing that fungi like water, they like very damp conditions, they don't like a lot of airflow, they like humid, and they like hot. And so if you can keep the temperature moderated and you get enough airflow through your crop, then you don't create humid conditions, and you also sort of get this balance with the water. Now we still need water, we just don't need an excess of water, because then the plant can't breathe. The plants are really no different than humans. Um, if you keep them underwater for a long time, they will die. They need oxygen as well. We have parasitoids, and so these are those beneficial insects. When we know that we can, for example, on the left we have this wasp that is going to basically put its eggs inside of this worm, and those larvae, the babies, when they hatch, they will essentially eat that worm as their energy source. Here you can see that we've got these eggs on top of this other worm that eventually that's just going to eat that away. Next, we have symbiosis. And symbiosis is mutually beneficial to both the host and the microorganism. So it is something that is good for both parties involved. In plants, We have a fungi that is called mycorrhiza, and that mycorrhiza is sort of like this extension that is going to be able to bring in more water, that is going to be able to bring in more minerals, particularly phosphorus for plants, and that is going to help the plant grow. If the plant grows, it creates more sugars that help the fungi grow. If the fungi grows greater, it takes up more minerals and nutrients and water that helps the plant grow to create more sugars that helps the fungi grow. So that's what I mean by symbiosis. Both parties, both organisms are going to gain some benefit by coexisting together. Maybe you've seen these on trees. We've got these lichens. It really just kind of looks ugly, but there is some benefit to it that they're going to, excuse me, again, provide some benefit to this. Let's just take this for example. This is a rock. I don't know that the rock gains much out of this, but the nutrients that are actually like the minerals that are actually in that rock are going to help that lichen grow. Now, rhizobium, those are definitely something that are important. So these are a bacteria that form these little nodules on the roots. It looks like an infection, but it's actually beneficial for this, particularly soybean. We use this particularly for soybean and maybe for peanuts. These nodules can actually fix atmospheric nitrogen, so we don't have to apply nitrogen fertilizer. And when we take in this nitrogen, the plant grows. When the plant grows, it creates sugars that feed those sugars to the nodules. Those nodules continue to grow, take in more nitrogen back into the plant. Plant continues to grow greater, bigger leaf area, more green, more photosynthesis, more sugars get traveled back down to the nodules. So it's this beneficial thing for both the fungi or the bacteria or whatever organism it is that is going to increase both, like the ability to thrive for both of those components. Next, we have these saprophytes. And so there's been this big sort of, what is the purpose of fire ants? There's a bunch of insects that were like, why do we have those? Well, those insects are basically deteriorating all the dead leaf material over time. And we don't recognize this. We don't necessarily see that the leaf material is being depleted, but it actually is. And so saprophytes and detritus, and ovores like omnivores or herbivores are breaking down those carbon structures and taking that energy back into the soil. So earthworms, we've got little small insects, and other small mammals are using that as well. So all big picture, we've got this, this food web of like this deciduous forest, and everything is energy for something else, and everything sort of lives in this ecosystem, and they found their niches such that everyone or everything can survive and keep everything in balance. And it can be this very intricate, complex system where when you take one thing and you change something, you're changing something with the other thing. And when you study ecology, you are trying to figure out one piece of this puzzle, but every time you figure that piece of puzzle out, you're changing something else. And that's really sort of what the ecosystem components all together, when we have to think about why our plants are growing where they're growing, or why they're not growing where we need them to grow. Okay. All right. So I think that's enough for this. I know this is about 45 minutes. I wanted to make sure that I got at least got you a video that you could watch. And I'll be making more of these and try and get those cut down a little bit better so that you can consume them. But if you remember, you saw I kind of had those dark bolded places for you to fill in those blanks. Those blanks, I would encourage you to start making note cards if you want to get ahead. And those note cards, those blanks are going to be for the open note quiz. That open note quiz will eventually be part of your online exam. All right. I hope that made sense. I look forward to teaching y'all the rest of this semester and sort of walking you through plant science and why that's important. And I'll try and make sure that from your get to know yous or from your knowledge surveys that I make sure that we hit all those topics. All right. All right. Y'all have a good Monday. We'll see you in the next video.